out of vodka lemonade. We show the cool kids how to be the youth of today. We jump the fence and play in Mr. Brogan's pool. Hit call the police and we hide behind the school. We spent hours throwing stones into the sea. They were the best days of my life, I promise thee. Oh, I could be a saint house, you would be the sinner. My mother used to frown when I'd invite you home for dinner. Oh, my darling, how I miss you to the day. I'd give my everything to see your face again. Oh, I'm so sorry, I've been distant in the past. I've written tons of letters and it ended in the trash. Oh, my darling, how I miss you to the day. I'd give my everything to see your face again, my friend. I remember falling so in love with you. I got a legend on the way. I'm falling for you, baby. What can I do to make you stay? The bassline's taking over. We've come too far to turn around. So turn the music louder and let my feet not touch the ground. 'Cause I'm in a daze and you're driving me crazy. Please can you stay, even just for a night? I'm losing my way, but don't try to contain me. 'Cause I'm still running. I'm in a daze and you're driving me crazy. Please can you stay, even just for the night? I'm losing my way, but don't try to contain me. 'Cause I'm still running wild. Running wild. Oh yeah. Running wild. Oh yeah. Running wild.
Hello, everybody. Welcome to the first CIS 115 Introduction to Programming and Logic live stream. Just a little bit of pre-stream stream safe, copyright free music there, so we don't get taken down for copyright infringement, to get you all a bit pumped up for class today, so we can get started and get ready and get raring to go. So let me just give you a bit of a rundown about how all of this works. So, I tried this last year for the first time with some of my classes. It worked out pretty good. One of the best things about this is having the opportunity for you all to attend live if you're able. Ask questions in the chat. I can see those live and respond to them if need be. And we can take care of things. So this is the first live stream. We'll be doing one of these every week, Monday afternoons. If we're not having a live stream, I'll let you know in class or in the Blackboard. So this week we are having this live stream here for Module 1, and Module 1 is introducing Python. And so this week's live stream probably not going to be quite as long as some of the live streams we'll have in the future. I like to keep my live streams relatively short that I have for the classes. We're probably looking at between 30 to 45 minutes for most live streams. If we get some kind of really heavy concept that might take a little while for, me to explain or something, then, it'll take a little longer. But 30 to 45 minutes in general. Today I don't have quite as much for you just because Module 1 really kind of eases us into it. It's a really kind of just general, basic, just nice introduction. So I thought I'd just kind of supplement some of the material that we already have in Module 1 and then just do a bit of a demonstration with some of the programming, just so we can kind of see how it all works. So let's get started. So first of all, what is Python? That's one thing where kind of the material in the course, it doesn't really do a great job kind of explaining where Python came from, how old it is, how well used it is, what this thing is. That's the programming language that we're going to be using this semester. So Python is a high-level programming language. And when we say high-level programming language, what we mean by high-level programming language is it's pretty similar to English. It's really readable by us human beings. And Python was created by a Dutch programmer named Guido van Rossum, and he was named benevolent dictator for life of the Python repositories until he actually stepped down from the Python organization a couple years ago, back in 2018. And this is actually an older programming language than a lot of people might realize. In recent years, it's gained a lot of popularity, mostly because of its, ease of use and kind of how we can make programs and make software and do things without having to, know a bunch of complex syntax. But it's been around a while, and we'll look at that in just a second. It's open source, so the base of the programming language and all of the libraries are all out there and available for you to look at. And it's community driven, and that's kind of part of being open source. Allowing members of the community to kind of be able to provide to the library and provide to the future of your language. Python's also widely considered to be what we call a batteries included programming language, and that's more of a colloquial term. That's kind of something that, that's kind of programmer speak, if you will. Meaning that out of the box, just with your standard installation of the distribution, You have a whole lot of extra modules and libraries and various other things kind of at your disposal that extend on to the base language. There are other libraries and other different parts of other different code bases that people have written to kind of extend Python, and you can install them into your distribution as well to kind of have more functions and other things available to you to kind of extend that code base. That's not something that we're really going to get into this semester, since this is just kind of an introductory course, and we're really going to be focused more on the basics of programming logic, that sort of thing. And then Python is a dynamic typed language. You also might call that a weak typed language. That's a sort of a synonym for that. Like if you're used to Java and some programming languages like that, that's a strong typed language. So when you declare a variable, which we'll talk about next time, when you declare a variable in Java, you declare a variable by declaring its type, whether it's a string, an integer, a floating point number, a Boolean, whatever, what have you. But in Python, you don't have to do that. You don't have to worry about what type of variable you have that you're declaring. In Python, you just declare your variable. Now, ideally, we want to be more specific, and that's something that we'll talk about a little bit. Insofar as explicit being better than implicit. These are concepts that we'll breach more next week. We'll talk about these things more next week in our live stream, as we talk about variables in Python and what we need to be doing with those in terms of how we declare a variable and how we work with a variable. But just know for right now that Python is dynamically typed. So just based by what you enter in as the value assignment for a variable, Python understands what type of variable that is and can work with it. So you don't have to get real specific with it. And that's one of the good things about Python, and that's one of the reasons why we wanted to use Python for this class, is that Python's a really friendly programming language for beginning programmers and really for non-programmers. This class is both in our programming and web development track and in our network management track, our networking track. And we decided to do that for a lot of reasons, and one being that in networking, one of the big things that is kind of the trend of how networks are being set up and established nowadays. In a lot of the classes that you're in right now, you're learning how to set up routers, set up switches, establish IP addresses, that sort of thing. Nowadays, in modern environments, the way a lot of that stuff is being done is through programming and through scripting. And, there are Python libraries where you can establish connections to servers, where you can set up server or router IPs and switch IPs and all the basic stuff that you've kind of been doing manually throughout a lot of your networking classes, especially the ones in the earlier levels. You can do those via Python scripts that are sent through certain frameworks. So having a knowledge of how programming kind of works can help you as you progress into the job market. And then maybe bigger than that is the idea of kind of thinking like a programmer. When we get into this, one of the things that this class is going to kind of focus on is the logic behind everything. Python is friendly. There's not a whole lot of difficult syntax to kind of remember. It's really similar to just regular old English. So when we get into doing a lot of the more advanced stuff later on down the line, it's not as difficult to wrap your head around the syntax as something like Java or C++ would be. So since that's easier, that gives us more of an ability to focus on the logic, focus on how we put different pieces of our program together in order to make it work right, focus on how we kind of think through the different steps. And this kind of thinking through the different steps is critical to the idea of problem solving. So when we take programming out of the equation just in general, and we look at, what we can do with the thought process behind programming, the idea of how we break down a problem and how we work to solve it is enormous. With the skills and things that we learn by taking up some basic programming and learning some scripting and doing that sort of stuff. So that's kind of the core of what we're doing in this class. So that leads us into the next question of why Python. So Python is one of the most widely used programming languages in the world today. GitHub, which is, many of you are probably familiar with GitHub, online code repository. A lot of places store their code in GitHub. A lot of big companies use GitHub to store code. At the end of the year, they do an assessment of all of the languages that are used to store code or to write the code that's stored in GitHub. And at the end of last year, they did this assessment. And Python was the number 2 most used language on GitHub. Number 2. The number 1 most used language on GitHub was JavaScript. So the number 2 most used language on GitHub, out of all the code that's on there, number 2 most used. And also when you think about all the different applications that Python's used for, data science, regular just scientific discoveries, like if you remember last year, the picture of the black hole, the very first picture of the black hole that everybody was making such a big deal over last spring, the program that was written to help capture that picture, because you can't just take it with a camera, you have to use multiple cameras and bend UV light around and straighten all that out and, manipulate it with code. The program that was written to help capture that image was written in Python. There are games that are written in Python. There are whole libraries written to help people create games in Python. Software, various, you can even have web servers in Python and develop web applications in Python. So Python is one of the most widely used programming languages in the world, and it's one of the most versatile programming languages that's out there today. And it's been around since 1991. And a lot of people don't realize that Python's been around that long. You talk about Python, and, it seems like it's only gotten popular within the last, 10 years or so. So you might not think it's been around that long, but it was developed way back in 1991. So, we're looking at 29 years there that Python has been in existence and been developed and worked on. Compare that to something like Swift, that's only been around 5 or 6 years now. Python's been around a long time. It's easy to get started with, and we'll see that as we actually work in it. And we're focusing on learning programming logic without having to struggle with syntax. And just kind of a fun fact out there, the reason why it's called Python, it's like when you look up images based on like Python and you like see book covers with Python, like it calls upon the imagery of the snake a lot, right? Because it's Python, Python like the snake. But actually the name was derived from the television series of Monty Python's Flying Circus. Guido van Rossum being a big fan of that show, thought it would be neat to name his programming language after that. And insofar as we have some examples in our class material, some of them will reference some stuff from Monty Python's Flying Circus just as kind of an homage to the show that gave, that is the namesake of the programming language. So there's that. So with that being said, that's the only kind of slide material that I want to cover today. From here, I want to kind of jump over to my REPL.IT window, and I will zoom in a little bit here. So you can have a bit of an easier time. One more. So, Python's a really easy language to use. And we can see that Python's a really easy language to use when we start to play with it. Like the most basic hello world for Python is simply print, open parenthesis, quotes, hello world. And that's it. The hello world traditionally is one of the first programming languages that we utilize in any kind of programming language, simply because it's kind of it's one of the easiest programs that we can kind of run, and it's kind of telling the world, like, hey world, we're learning this, we're making our mark in this programming language. So print hello world, and let me zoom in here so you can see a little better. So print hello world. Really, really simple. Which is why, in most of my programming classes, I say, one of your first assignments is to do the hello world. But in this class, I say, you don't have to do the hello world. Because this is what? This is simple, right? I run this, and we get hello world in our console. Now that's all well and good, and we see that it works like that. But we're going to want to do our programming right. So we're going to want to do some things, some other things with our programming that's different than normal. We can work without these things in our IDE, but in the real world we need them. Or really, it's a best practice to have them. So we should become accustomed to using them in our programs. And the first thing that we need to become accustomed with is the shebang. The shebang, the funny name for something that is kind of important in Python. We discussed the shebang in, your module reading material. And what the shebang does is it essentially tells the Python interpreter which version of Python to use to interpret the code. Now, there are two different commonly used versions of Python. Python 2 and Python 3. When you create a new REPL and you create one with the regular Python name, it's giving you a Python 3 REPL. So technically when you do that, you're in the Python 3 environment, so you don't really need the shebang because it's going to give you that by default. It's going to give you the Python 3 environment by default. You can create one with the Python 2.7 environment, but it's not recommended. There are just slight differences between the two. And Python 2 is actually on its way out. It's being depreciated, and it won't be used any longer, or won't be in distribution any longer here very soon. So we may as well just kind of put that out. However, when you get into the real world and you're programming Python into the real world, you might be in an environment where they have both Python 2 and Python 3 running on the same system. Python 2 for legacy scripts, Python 3 for new stuff. And that makes the shebang exceptionally important because you need to say, oh, this is a Python 3 script or this is a Python 2 script. So you need to be able to tell the interpreter which version of Python to use to interpret this program, to interpret this code. So that's why we need this shebang. And so the shebang gets its name from the first two characters that are in the shebang. The hashtag or pound symbol or whatever you want to call it, and the exclamation point. So when you hear shebang, you can kind of think hash bang. A bang is kind of another name for an exclamation point. So that's where we get the name for this shebang. Then we add in our file path. User bin env environment. Add a space and then Python 3. And that is our shebang. So with that line at the start of our program, every time that this runs, the interpreter will read that line and say, okay, I need to use the Python 3 interpreter to be able to decode this program and use it properly. So we want to make sure we include that line there. So that's great. The other thing that we want to make sure that we use, and this one's a little bit more technical, if you will. Because again, we could just add our print statement in here and be fine. But there's an if statement that we want to add. And we'll talk about if statements and what they are and how they work a little later on. But in this case, we don't really have to know what the if statements do yet to add this if statement. So if underscore underscore, that's two underscores, name, underscore underscore, equals equals, quote, underscore underscore main underscore underscore. And then we'll put a colon out at the end of that. So essentially all we're saying here is that if this is the main part of our Python file. You know, when we get into writing other functions, we'll have other functions in here, and we'll want to kind of delineate our other functions from our main function. And so this helps us kind of do that. So if the function is main, or if it's a part of the main file, if it's a part of the main part of the file, then we can do whatever. Now the thing about Python, and the thing about that you might have a little bit of struggle to learn, is that Python doesn't use semicolons, doesn't use curly brackets like a lot of other programming languages. What Python uses instead is it uses some positional formatting. It uses tabs to determine what goes with what. So now that I have this if conditional, everything that goes underneath this if conditional needs to be tabbed in 1. And it's technically not a tab, even though I'm referring to it as a tab. It's like 4 spaces. But thanks to using an IDE like we have here, then we can use the tab key and it interprets it as the regular Python 4 spaces. And even if we just use a line break, since it knows that everything that goes under there has to be tabbed inward, it's going to automatically tab over for us. So now from here, I can type our print hello world. And now this is a more proper hello world in terms of what we want to see for best practices. A little more complicated, but really the part that's doing all the work is the same. It's just this one singular line here. So when we run that, we get the same results as we got before. Hello world. Now, one last thing before I end the stream for today. For right now, we're not getting too fancy. We're just using Python as a glorified calculator. So one of the things that you'll want to do is you'll want to be able to do math inside of your print statements. So if I wanted to calculate 56 plus 17, it's as simple as that. 56 plus 17 is 73. If you wanted to get more complex with your calculations, you need to remember that Python follows the PEMDAS rules. PEMDAS. Let's scribble that up here. PEMDAS. For order of operations. Parentheses, exponents, multiplication and division, addition and subtraction. Right, so it does things in order, that in the same order that you might have done them back in algebra class or math class or whatever, back in high school. So if I said 16 times 12 plus 3, it's going to do the multiplication first and then add the 3. Right? To give me 195. Now, if I wanted to make sure that my addition was done first, the way I do that is I put parentheses around them. And just like that, I took that one little section, moved it up in the order of operations, because parentheses goes first. And it's 240 now. Same numbers. Same exact numbers. The only thing that I changed was I changed the order of operations in which the math was being done. So that's something that you have to consider as you're thinking about, okay, well, I got this lab that I need to do, and I got these equations that I need to create to be able to do this lab. So how do I make sure all the math in this lab is being done correctly? You got to think order of operations. You got to think, do I need to put anything in parentheses to make sure it's done first? So with that being said, we've gone about 30 minutes. We've actually gone a little over 30 minutes. So I'm going to go ahead and stop here for today. I'm going to turn on the music again, hang out and chat for just a moment, just in case anybody has any questions that need to be answered. But again, that's all that I have for you today. Thank you for watching, and we'll see you next time.
I think everyone wonders what we would do if they saw a ghost. I think everyone wonders what we would do if they saw a ghost.
I'm not afraid of your ghosts, Bridget.
I think everyone wonders what we would do if they saw a ghost.
I'm not afraid of your ghosts, Bridget.
I think everyone wonders what we would do if they saw a ghost. I think everyone wonders what we would do if they saw a ghost.
I'm not afraid of your ghosts, Bridget.